Welcome back. So, in previous lecture we talked about alluvial fans, and I have explained that how alluvial fans are formed and what are the reasons for that and why they are. We have high hazard closer to the proximal part and less hazard or the lower hazard at the distal part. So, this is another example. So, this portion will be having the proximal part will have higher hazard, the middle part will have moderate, and the lower part will have lesser hazard. This photograph is again the corona satellite photograph, and as I told that even if you go to the Google Earth image, you will find these features very prominently seen, but here there is again the foothill zones of Himalaya, and you can clearly see what we have discussed. Okay. So, the channels are having very confined flows here. Okay. And as soon as it is debouching into the plain areas, alluvial plain areas, then they are becoming unconfined. Okay, with have multiple channels here. So, these are all alluvial fans. Okay. So, this you are having one here going, another one. This is what we call coalesced alluvial fans. Okay. So, you have multiple fans here, smaller one for the smaller rivers, and then so mainly you can see here. Okay. So, this is the front. Okay, we can say this is the demarcation geomorphic boundary here between the hills and the alluvial plains. So, this is your Indo-Gangetic plain, and this is your sub-Himalaya, or you can say Shivaliks. So, amongst the mountain chains on Himalaya, this is the youngest one, which is close to the Indo-Gangetic plain. So, this is the again, as we have talked about, that the change in the gradient will allow the formation of the alluvial fan. Now, this is close to the water body. Again, there is a change in the gradient here, and this is again a very similar landform, what we call the alluvial fan. Okay. So, you are having the alluvial fan deposit here, and this portion is also been termed as pediment, or we can say the Piedmont zone. So, this is what we are having the pediments or Piedmont zone. So, pediment, a sloping surface at the base of the mountain formed due to erosion covered by thin veneer of alluvium. Okay. So, alluvium is a loose material or river driven material. So, this is an example of that, which you can see that this is the area where you are having the debris slope, and the material, alluvial material, will be deposited here. This has been termed as the pediment and also termed as the Piedmont zone. So, the area of deposition developed adjacent to the Himalayan foothills or any foothills, okay, mainly by the stream debouching into the Indo-Gangetic. This is the case we have talked about the Himalaya and Indo-Gangetic plain, and they will have the coarser debris close to this. So, this has been termed as the Piedmont zone. Now, again, this is an example where you are having the central Himalaya, where you are having Haldwani here, and this is the area where you go up to the Nainital. Okay. So, again you can see this very clearly that there is a confined flow here, and this again I am using the Google image. Okay, I am using the Google image here, and this is all what we see here is the major fan, and this has also been termed as, because this is channel which is flowing here is the Gola river, and this has been termed as Gola fan. Now, the last landform, which is the one of the major landforms, is again very similar to fan, but this is not forming at the base of the foothills. This usually form where it goes and the river goes and meet the ocean, or ends its journey and meet the water body, or maybe an ocean, we can say. So when a stream enters the standing water body, you can say of the sea or a lake also, okay, its speed drops rapidly. Its ability or to transport the sediment decreases, very much similar to what we were talking about the alluvial fan. So this will again will be having a sort of an distributary, that what we initially discussed about, that if you start from the source area, then you are having the tributaries, then you are having a trunk stream, then finally you will have the distributaries, okay. So this will have a distributaries here, okay. So a fan delta typically is built adjacent to the mountain fronts, and the braid delta is a coarse grain delta constructed by a braided streams that builds outward into the standing body of a water. So these are the example. One is the braid delta, and as we talked about, that the braid delta will have the coarser bed load, okay. And this one, which has been example, which has been shown here, this one is a typical named as an bird foot delta. The reason is, again, if you carefully see this, is very typical to the shape of the bird foot, okay. So these are basically the fine grain, but this will be the coarse grain braid deltas. Now one of the best example what we have is your Ganga Brahmaputra delta in India, and that is one of the largest, okay. So if you, this is an example of the stream getting into the water body, depositing a delta, and the term which has been coined, okay, the delta, as we were talking about the fan and all that, the delta is again a Greek term, and it comes from, because it gives in shape of the triangle, and that is the reason why it has been termed as delta, okay. So as I told that this is one of the best example we have in Indian subcontinent. So you have in Ganges, and this is the both the river meets here, like Ganga and Brahmaputra, and that is the reason why this has been termed as Ganga Brahmaputra of delta. So this is one of the I would say the largest delta, okay, like covering almost 1 lakh square kilometers, and the area which has been covered here is the Sundarban region, okay. Now one more example which I would like to discuss here is that about the active fan, and this comes from Bihar actually, okay. So this is what you see is the Himalayan front here. So you have Patna here, this is the alluvial plains, Indo-Gangetic plains, and there is a very sad story about this river, that is Kosi river. This is in Kosi river. So if you carefully look at again what we were talking about, that you are having confined flow, then you are having getting unconfined here, okay. This is the active channel now, but the fan goes like this, okay. The fan boundary is somewhere over here, and if you see the close up of this one, then you have multiple channels which exist, okay. Now these are all its older channels, okay. These are all older channels which you see, and this river has a tendency, so you can see it's a lot of meanderings which are meandering channels which are seen here, okay. So this one is the present day course of the channel. So you are having like braided channels and combination of the straight and the meanders which have been seen here, okay. Now this channel, that is Kosi, has a tendency to reoccupy its own channels, okay, own paleo channels. Now what has happened is that with not having a proper understanding, people have been allowed, of course, as we have discussed in the beginning also, that why humans have that tendency to go and settle down close to the river channel, and most of our ancient civilizations were also flourished along the river channel. And one of the best example is along the Saraswati river, and that was your Indus Valley civilization or Harappan civilization. Now, here in this case, as I told, that this channel has a tendency to reoccupy its own paleo channels. I would say paleo is ancient or older channels, so we term this as in paleo channels. So it tried to occupy that, and this type of incidents have happened in last 100-200 years. That is as per based on the records, okay, and then people who have experienced that, okay. So this is as per the record, the migration of the channel. Some geologists they believe that this formation of this Kosi fan has been governed or been controlled by two faults, subsurface faults. That is, these are the two faults, Begusarai and Bhavanipur faults. It may be possible, okay, but and then there are multiple lineaments which are also responsible for the migration. That is what their interpretations are. But the main part which I would like to highlight here is that the shifting part, okay, and that again poses the hazard, okay. So these are the records in the historical chronicles which talks about that. Even this, if you look at this, is 1770, the channel was occupied along this path here, and this is since 1950 and 1963. This is the present condition. 1933 it flowed here, okay. And recently also it happened that one of the channel which got active here, okay, and many people were been killed because of that. So and this has also been termed, and that is one of the reasons this has also been termed as sorrow of Bihar, okay, because this always gives trouble to the people who are settled in this area. Okay. Now, along with what we have looked at is till now is the channel pattern, and now what we are going to talk about the drainage. So let us look at the drainage. Basin evolution we have already discussed in the beginning, but apart from that we can also use morphometry to understand the dynamics of the fluvial system, okay. And of course the drainage pattern will also help us to know the subsurface material or the lithology of the area. So fluvial geomorphology, we can have the linear aspect of the channel systems, okay, aerial aspect of the drainage basin. We can talk about the channel geometry. We can talk about the process domains and integrated hydrology and geology. Okay. We'll try to put in this course, we will try to look at few of them, not all, but I hope you will enjoy that. Okay. So linear aspects of the channels, what we look at is the surface area, that is your basin area, drainage pattern, stream orders we will look at. Okay. We'll try to see that what are the and how this can be used for different hydrological purposes, and what will be the role of the surface area of the basin and the drainage pattern also, as I told in the previous slide that this will help us in identifying the subsurface material what exists. Okay. Based on the stream orders and all that, we will also do one exercise on bifurcation ratios and why they are important, that also we will discuss. Okay. And drainage density again. So this two will be connected. Okay. Like drainage pattern and the drainage density, because this depends on the your subsurface lithology. So there are many like methods which are available. There is like one is known as Teller, another is Hutton. So we will use one of them. Now, what is the way to categorize the channel, or we can say the stream orders mainly. Okay. So these are, you can give a number here from 1, 2, 3, 4, 5 or so on, and then the number of streams of the, you can say that this is the order of the streams. Okay. So first order, how many streams are there, second order, how many streams. So this will help you in talking about the bifurcation ratio. So here what has been shown is that you have the main basin you have here, and this has been based on the trunk stream. Okay. And then you have sub basins which are been given here with the dotted lines. Okay. These are all your sub basins. Now, two first order stream joining at a point and further downstream will give you the higher order. So this is how you are going to talk about the stream orders. Okay. But if the first order stream, because there is no other stream joining here, so this will remain the first order. If there would have been like another stream which was joining here, then this could have become the second order. Okay. But this remains the first order because there is no other stream joining here. So this remains again the second order. But when two second order streams joins, because there is a bifurcation here, so this becomes the second order. So when two second order stream joins, the further downstream will become the third order, and so on. So you are having the third order, two third order joining here. So the trunk stream will become your fourth order. So this basin, the main basin, is your fourth order basin. This is how you are going to talk about the bifurcation, plus you will talk about the ordering of the streams. Okay. And nowadays, so this is for your understanding, but now we are having the softwares which are available, which immediately gives you the stream orders. Okay. Now what we need for that is that for the stream order, that what you have been learning right from the beginning. So once you will have, like, you are going to use stereo photos or images, and then you will generate anaglyph, and third you will generate DM after that. Okay. And with this, when you give the input of this to your software, which you are using the QGIS, you will be able to extract stream order, or I would say that you will be going to get the drainage of the area. Okay. So there are steps which you are going to do, and then you will follow this for doing this exercise. Okay. Now coming to the drainage basin, as we have discussed in number of slides, this is how we are going to talk about the. So marking the drainage divide, keeping in mind the elevated portion, that is your ridge line, and the drainages which are flowing on either direction. Okay. So these are flowing, this is flowing in this direction, this is flowing in this direction. So this is coming into this basin. Okay. So this will become your major, or you can say the large drainage basin, the main drainage basin. Okay. So this also you can mark here. Okay. So this goes like this, and then this goes something like over here. Okay. So this is another basin which you are having over here. So mainly based on the drainage divide, you will mark your drainage basin, which has been shown here. That this is the elevated portion, this is your divide, and then you are having the smaller streams joining, and there are tributaries joining the main stream here. So this is another example of your drainage divide and the basin area. This part we have already discussed, so I'll just go ahead, but this is what we can, this will help us in understanding the bifurcation of the channels. Okay. So you are having the smaller streams which are developing and joining, so these are getting bifurcated further in the headward side. Okay. And that's how the basin has been evolved. Okay. Another landform which is again important is your terraces. Okay, which represents the older abundant alluvial floodplains. Okay, they mark an older relative high water level. That means that the river flowed at that point in the past. Okay, and mark as a step or a scarp. So it will mark something like this. Okay, so you are having a channel here and this, and it can have multiple terraces. Okay, multiple steps like this. So this is what we'll see quickly. So if you are having in floodplain here, and then you are having the uplands on the side, so slowly all channels or the river basins will have the terraces. Okay, and these are also depositional and erosional terraces. We are not going to get into that part, but we will be interested in marking the terraces. So this becomes the higher surface, and this one is the lower surface, and we can say that this is what we are having the youngest terrace. Okay. So mostly we will need to understand that how many terraces are there in the area, and that also helps us in allowing the people to settle down. Okay. So this is another advantage of that. Okay. Now for example, if you combine what we were talking about, the levees, so there is a terrace which is sitting here. Okay, this is a terrace here, this one. So this is a terrace, this one here. Okay, and this is a part of the floodplain, active floodplain, but along with the levees here. But during flood, peak flood, if even this levee has been overflown, then this portion will be, like we can say, inundated. Okay, so that is what has been shown here. So this portion is inundated, but this terrace remains unaffected. So you need to look at that, what is the peak flood which has been experienced by a particular drainage basin or a channel, and how many terraces are there or exist along the river valley. So we can also demarcate such landforms, which helps us in the landscape evaluation. We can evaluate the landscape, and we can identify the best areas to locate our citizens. Okay. So with this I'll end here, and there are few more things which we will be discussing about the bifurcation ratio and stream order in the next lecture. Thank you so much.